Hi, welcome to your lesson on inverse functions. This is a fairly big idea in mathematics. Let's make sure we understand the concepts. First of all, let's grab the page you were given in class. You're going to add some notes to this. We're going to define inverse relations to begin. Inverse relations are the set of points obtained when all x and y values are interchanged. Remember this is the key to all work that we're going to do with inverse functions. And another note here is the inverse will be a function if the original, and that means the original function, passes the horizontal line test. You may remember learning the vertical line test. Now we're going to look at something called the horizontal line test. Let's begin with this table of values here in this graph here. Please ignore this green line for now. We're going to use it a little bit later. So here's an original function, and it's this set of points. From those points, we're going to create the inverse function, or at least a set of points that are on the inverse function. So this symbol here, when you see that f with the little -1, that means inverse. Don't think of that as an exponent. Just remember this means inverse. So again, the definition of an inverse function is the function that is obtained when the x and y values are interchanged. So for example, this point here, -5, 0, on the inverse will be 0, -5. All we did is switch the x and y values. So do that for the rest here, and let's see what set of points we get. Well, the first one's 1, -3, then 2, -1, 2.50, and 3.52. All we did again is switch all the x and y values. So now let's plot both of these to see what these two functions look like. So these points will be plotted in black. So here's the first one, -5, 0, -3, 1, -1, 2, 0, 2.5, and 2, 3.5. Now let's connect those. There's a line that's graphed with those points. Now let's do in blue. We'll do the inverse. First one is 0, -5, 1, -3, 2, -1, 2.50, and 3.52. Connect those as well. Now, do you notice anything, some kind of relationship or a connection between those two graphs? Is there anything you notice? Well, hopefully you saw that there's some kind of, they look like they're mirror image of each other, but mirror images across what line? Well, they are definitely reflections of one another across this line. This line that passes through the origin and has a slope of 1 is the line y equals x. So please add that line, dotted line, to your graph. That is the line of reflection for these two, and inverses will always reflect across that line, y equals x. All right, so that is what happens with every inverse. We've looked at all kinds of reflections, reflections over x and y axis, but now there's reflections across this line, and that happens when you have inverses. So this question says, is f of x a function? So if you remember, the definition of a function is a relation for which every input produces only one output. So we use something called a vertical line test to check if something's a function. Basically, if a vertical line passes through a graph only once, at every location, then we know that this thing must be a function, because if it only passes through once, it is saying that for every x value, there's only one y value. So let's move that line over, and let's do that again across the black function there, sorry, across the black graph. It only hits it once everywhere, right? And also on the blue one, the inverse, it only hits once everywhere. That means both of them, the original and the inverse, are both functions because they both pass the vertical line test. The vertical line hits both of them only once at every point. So the original is a function, yes. Is the inverse a function? Yes, they both are. But that won't always be true. Sometimes the original will be a function, the inverse will not, and sometimes the inverse will be a function and the original will not. So paper folding time. Why does it say that? Well, I want you to actually take this paper and fold it along this dotted line right here, the line of reflection, and then fold it over so that this graph goes towards this graph. Now, if you have drawn perfect inverses and you're folding along that mirror line there, then this graph should lay right on top of this one when you fold it over. So double check that that's what happens, because that's how inverses should work. So now let's try inverse from a graph. Here we're given a graph of a parabola, a quadratic function, and we're going to try to draw the inverse. Well, in the last problem, we had some points and we could just interchange the x and y values. Here we don't have a table of values, but there's still points. There's infinite points along any graph, so we can choose some of those points and create inverses based on those. So I'm going to choose some points that are easy to find on here. Here's negative 4, 8. Another easy point is negative 3, 4. Here's negative 2, 2, and 0, 4. So those 4 points are pretty easy to spot on the original. Now if we take those and exchange or interchange those x and y values, then we can create the inverse. So this point here on the inverse would be 8, negative 4. So here's 8, negative 4. The next point here would be 4, negative 3 on the inverse. So it's 4, negative 3. This point here on the inverse would be 2, negative 2. We've changed the values. And then this point here, 0, 4 on the original, would be 4, 0 on the inverse. So connect those and you have the inverse. Notice that you can see that there are reflections. This one here, if it was flipped across that line which we should add to here, which is y equals x. So again, graph that line. That's our mirror line. This thing here, this parabola, would reflect and end up being over here. Imagine it flipping over. And again, you can fold the paper on that line. Fold it over and you'll notice that this parabola should sit directly on top of this one. So let's check. Is the original a function? Well, let's use the vertical line test. So here's a vertical line. Let's go again. Does it always hit the original, the red function, only once, or the red graph? Yes, it never passes through the red graph more than once at one point. So that means the original is a function. But then look at it as it goes across on the inverse. On the inverse, it hits twice many times. That means for one x value, like for example for 8, there are 2 different y values here and here. So for one input, there are 2 outputs. So this is not a function, even though this one is. So is the original a function? Yes. Is the inverse a function? No. And how is the horizontal line test? So now we're mentioning the horizontal line test. So back in the beginning of this page, it said the horizontal line test is used on the original to tell you if its inverse will be a function. So now you see this horizontal line. And notice as I go down with that horizontal line across the graph, that horizontal line hits the original twice at many points. So that's how we check if the inverse of the original will be a function. And why does that work? Well, let's think of it this way. If on the original you're doing a horizontal line test like that, and then you reflect that graph over here. So imagine you reflected that horizontal line. If you reflected that horizontal line, it would become a vertical line on this one. So by doing the horizontal line test here, it's the same as doing the vertical line test here. So you can perform the horizontal line test here. If it hits twice, then you know automatically the inverse, even if you don't have the graph of it, you will know that the inverse will not be a function, because if it passes twice here, the vertical will pass twice this way. All right, so here's some images that show horizontal line test. Here's a function. We're going to do horizontal line test. And does it ever hit the graph twice? Well, on that one, no. So that means this graph, if you took the inverse, it would also be a function. All right, this one. Yeah, that horizontal line passes through this graph more than once, many times, right? So that tells you if you inverted this one, if you made an inverse, the inverse would also not be a function because it would not pass the vertical line test. Here, let's see. Well, it's this sideways parabola. This one only hits once at every point. It can only hit the graph once. That means it passes the horizontal line test. That means if you made an inverse of this one, which would end up being a parabola like this, that parabola would be a function. But this one here is not a function, right? This one here fails the vertical line test. So not a function, but if you made the inverse would be a function because this one passes the horizontal line test. The last one here, it's kind of hard to see, but in the middle here, right here, it kind of flattens out. In the middle there, this line does hit this thing twice. So this means that this does not pass the horizontal line test, therefore the inverse of this would not be a function. All right, one last thing, add this to your notebook. You're going to have an assignment that goes with this video. To do the assignment, you have to know this idea here. So we're going to have the original function, and we're going to find the inverse of it. So it says find the inverse here. To find the inverse, you always begin with the function, and we're going to use what the definition of an inverse is, right? So here's the original. Instead of f of x, we've written y here. The definition of an inverse says we interchange the x and y values. That means I'm going to rewrite this one, but I'm going to write x here and y here. So here it is. X goes there now, and y goes here. By doing that, by switching the x and y, you have created the inverse function. This is already now the inverse. And now to have this one in proper form, we're going to solve for y. So multiply everything by 2 first to get rid of this fraction. Then add that 2 to this side, so we have 2x plus 2. So we've resolved it for y. So again, we created the inverse by exchanging the x and y here, and now we're just switching things around so that we've solved it for y. So the inverse, now that y is replaced with the symbol for inverse function, so this is the inverse of this original. And when you graph them both together, you notice they definitely look like inverses. There's a line of reflection, and that one definitely looks like a reflection of that one across that line. And you have to know in this assignment, or remember how to graph lines, of course, because you have to graph the inverse and its original, the original and the inverse together. The original is this. Here's our y-intercept, -1. Here's our slope, 1 over 2. So you go up 1 over 2, up 1 over 2. There's that line. The inverse has this equation, so y-intercept of 2 right here, and the slope is 2 over 1. So you can go down 2 over 1, down 2 over 1. So there's the two graphs. Right, so practice assignment will have you practicing these ideas a little bit more. Make sure you work hard on it and check your answers on the back page. You can do it.